Hi everyone. Today we're going to talk about linearizing data. So you may need to linearize a set of data if the relationship produced is not linear. When the relationship produced is not linear, then it can be difficult to write a math model for that particular relationship. So a great skill to have is to be able to look at a graph and decide what type of relationship you see and understand in terms of math how we can modify that data so that it produces a linear relationship, and then we can very easily write an equation. So I have over here on this Excel workbook two physical quantities that were collected in the lab. And so what happened was we have students who have a long ramp, and they put the ramp on an incline and they release a marble. And every second they collected the position of the marble in centimeters. So you can see here in Excel, don't forget that you want to put your independent variable first, followed by the dependent variable. And when you make a graph, right, the title of the graph is going to be the dependent variable versus the independent. So the graph that's produced from this data will be position versus time. However, we input the data as the time and then the position. So in order to make a graph of this data here, we're going to highlight the data set, go to Insert, and we see a number of options here. We're interested in a scatter plot, so I'm going to use this scatter with only the markers. I don't want a line because I'd like to really think about the line of best fit myself and think about all of the possibilities and really what's going on in terms of the math here. So I'm going to choose scatter plot, and I get this really nice graph. And I can tell as soon as I look at this that this is not a linear relationship. The slope of this graph is definitely not constant. It looks here like I have a small slope, and that over time the slope is increasing. So I'm just going to take a moment here to add in the chart title and the axes labels. So in order to do that, how I got to that menu was I went to layout while I had the graph highlighted, and I get a lot of options here that allow me to format the graph itself. So we're going to go to chart title, and the title is position versus time. It's always going to be the y quantity versus the x quantity. The next thing I'm going to do is add the axes titles, and I have a choice. It doesn't matter which one we do first. If we go to horizontal here, that will be our independent variable. This will be our time. I want to put in the physical quantity time, and then in parentheses the units in which it was measured. So I have a lowercase s here for seconds. Next, I'm going to add the vertical axes, and this is going to be position, and the units it was measured in are centimeters. Now I kind of don't like how this title is in the way of the axes here, so I'm just going to resize the graph a little bit so that I'm avoiding that. Okay. Now as soon as I look at this, I recognize what this relationship is. I recognize that this is not linear, and so I'm just going to put some notes over here. This is not a linear relationship, right? This is actually a parabolic relationship, and this happens to be a top opening parabola. And if I think about this, as x increases, so in this case as time increases, we can definitely say that y increases. But as time increases, y is increasing at a greater rate than time is. So we have a parabolic relationship, and we know that y here, right, is proportional to x squared, right? If you want to get the square function here, you need to go over to your font menu, and I'm going to expand this for a couple more options, and I'm interested in a superscript. So now I can have x squared. Now I need to turn off that superscript, so I go in the exact same way. In order to linearize this, to linearize a top opening parabola, I'd like to graph not y versus x, but y versus x squared, right? Okay. At this point, I want to show you why Excel is a really nice program when we're dealing with data sets like this. My ultimate goal is to take this position time data and modify what I'm graphing so that it produces a straight line. And then from there, I can write an equation. So in this case, I'm going to attempt to linearize this graph by making a test plot of y versus x squared. So what that means is that for our case, we're going to graph, what was our y value? Position versus not time, but time squared. So I'm going to prepare my x and y data. So I have this set up, and this time, instead of time, I'm going to have time squared. So my units won't be seconds anymore, they'll be seconds squared. The other heading is going to be unchanged, so I'm still going to have position as all of my y values. Now with Excel, we can copy and paste data that we already have in the workbook. So underneath the position column, I'd like to copy the data from our original data set. What I notice here when I do a cut and paste is I notice here that this goes from row 4 to row 11. Okay, so that's a total of 7. I'm just going to keep that in mind as I copy it. Once you copy the data, you see that the solid line now turns into this running line. If I start at 16 and I know that I'm going to need 7 rows, that means I'm going to end up at 23. So I'm going to highlight this and just click paste, and all of the data now has been pasted for you here. The next thing I'm going to do, and I'm just going to center time so it's easier to see here. The next thing I'm going to do with time is I'm going to write our first formula in Excel. So in order to write a formula or a function here, we're going to click in the cell with which we would like that formula for. So in this case, this is going to be A16, so I've clicked here. And now if I go up to the box at the top here, and I put in the equal sign, I'm telling Excel here that I'm ready to write a function that I would like this box to produce. Now, because I want to use the data from my original data set, I'm going to click on the cell that I'm interested in. So the first data point, I want it to be not time from A4, but what the result of squaring the A4 cell would be. So what I'm going to do here is I'm going to click on cell A4, and you can see just by clicking on it, the formula has updated. In Excel, if you use Shift 8, you'll see that you get what looks like to me like a star, okay? And that means multiply. And I'd like to multiply time, by itself. So I'm going to click on the A4 cell again. And when I hit enter in A16, now I have time squared. I would like that to happen for all of the data points after the original one. And you don't have to enter the formula over and over again. If you look right now, the cursor looks like almost a three-dimensional cross. If I bring it over to the bottom right corner, the cross changes. When I do that, I'm able to now drag that cell down and copy the formula. And so I've copied the formula for all of these subsequent cells, and you can see If you go back to the original, 1 squared is 1, 2 squared is 4, 3 squared is 9. So it very easily has copied the formula for you. Now, if we were correct in thinking that this relationship was in fact a parabolic relationship, then when we graph these, we would expect to get a straight line. So we have a way to test this. We've highlighted the area here, and I'm going to go to Insert, Scatter, and what do you know? There is a beautiful linear graph. I'm going to just drag it down next to this data set, and I'm going to take a moment now to add the titles and the axes titles as we did before. So I've added the axes titles, and notice that that x-axis title is no longer time but time squared, and the units are seconds squared, so they match. Position over here on your y-axis has stayed the same. And now we have this beautiful linear relationship. So now I can say that this graph is a linear relationship. That means that it can be modeled by y equals mx plus b. For us, our y is equal to position, right? And you might use for position the symbol x. It's a symbol that we use in physics. Our x quantity is time. Now I'm interested in finding out what the slope is. Now there's a function for slope. If you wanted to do that, you can. There's also an easy way to get slope. If you click on the points that you have here, and then you right-click on any one of the points, we can add a trend line. The next thing that you'll get is this box with a lot of options, and I know that this is linear, so I'm going to leave that circled in. And then I'd like to display the equation on the chart and the r squared value. I'm just going to move this where I can see it. Now this equation, is not foolproof. I mean, if you look at your data, you have at the clock reading of 0 seconds, you have a 0 position. So I know that my y-intercept, or my b, is most likely equal to 0 centimeters. However, with Excel here, they've taken all of these points, which have some uncertainty in them because they were actually measured in the lab here with measurement instruments. And so this 0.08 to me is not really that important. I can go back into the add trend line, and I could actually set the y-intercept to 0 because I know that it's 0. If I do that, and I request to have the equation and the r value on the chart, notice that for the equation here, we have a b of 0. The slope, according to the equation on this graph here, is equal to 3.0011. So now we have all of the ingredients here, right? Y equals position, x equals time, the slope is 3.001, but this slope actually has units on it. Slope is change in position over change in time, so this will have units of centimeter per second. And now this allows me to write a complete equation for this relationship. So instead of y equals mx plus b, instead of y, I'm going to put position, which has the symbol x. The slope, which for this is 3.0011 centimeters per second, times time, little t is the symbol for the time. And then we're going to add in that 0 centimeter y-intercept. And now I have an equation for this graph. I hope that you found this example of how to linearize a graph helpful for your future study in physics. And if you have any questions, please let me know. I hope you have a great day.